Welcome, Algebra 2 students, to the homework help video, page 429. These numbers right here, let's go ahead and jump right into this now. For numbers 5, 6, and 7, the directions say to evaluate without using a calculator, okay? Now, number 5 is a natural log, ln, natural log. So really, you understand it's not normal to write it like this, but when you see a natural log, it means this right here. This means this. Got it? So I can put this in place of this and then put e to the fourth. Now once I do that, remember what I've taught you. Anytime these two numbers match, and don't forget, e is a number. Anytime these two numbers match, all of this is gone and your answer is just the exponent. So your answer is 4. Another way to look at this is simply this. Let's look at it like this, okay? Log base e of what? E to the fourth. What does it equal? We don't know, so we say x. Now write that exponentially, so this base becomes a base. This by itself becomes an exponent. The argument comes over here, and look what you have. E to the x, e to the fourth, so obviously x has to be what? 4. E to the fourth equals e to the fourth. Either way you get 4, okay? Understand this, and make sure you get this, okay? Number 6. Okay, same thing, guys. Look, natural log. This right here means logarithm base e, and then bring down your e to the negative 2. Whenever these two match, your answer is just the exponent, so your answer is negative 2. Or if you prefer, you are more than welcome to write this exponentially. Say that this expression here equals x, and so we'd have e to the negative 2 equals, bring e over e to the x. And look, x has to be negative 2 because e to the negative 2 equals e to the negative 2. Number 7. Alright, now this one's going to be a little trickier, okay? Watch. This means logarithm base e of this right here. Now we do not have a base matching a base at all. We have 1 over e to the third, okay? Now, there's a couple of different ways to do this, okay? First of all, we can do it the old-fashioned way. Set it equal to what? X. And now write this logarithmic expression exponentially. So 1 over e to the third power equals, this is a base, so it stays a base. And this side over here becomes your exponent. Okay, that's one way to do it. Nothing wrong with that. Now, bring this e up top, and when you do, the 3 will become negative. So now I have, well, there's a 1 up top already, so I guess you could say 1 times e to the negative third. But 1 times anything is just itself, so really I have e to the third equals e to the third, or e to the x, excuse me. Well, obviously x has to be negative 3, because e to the negative third equals e to the negative third. There's another way to do this too, though, if you would like, okay? Another way to do this is to take your argument right here and kind of work with your argument. This is your argument right here. Now watch. 1 over e to the third. Bring the e up top, and we have e to the negative third over 1, or just e to the negative third. So now this entire expression right here equals what? E to the negative third. So I can write logarithm base e of e to the negative third equals x. And now bring this e over, so e to the negative third equals e to the x. Either way, you're getting negative 3. Make sure you understand those, okay? Now, numbers 5, or numbers 8, 12, 16. 8, 12, and 16, we're going to use our calculators, okay? So for number 8, you would type in your ln button, and I think on your grapher it's capitalized, maybe, like this. Why, I don't know. It's never written like that in mathematical books, but hit your natural log button, your ln button, and then type in 1.4, and then hit enter, and you'll get this. Number 9, type in your, well, I'll tell you what, you can type this whole expression in. Type in 4 to your calculator, because there's a 4 here, and then hit your natural log button, and this will pop up. Put in 6, then be sure and close the parentheses, because if you don't, note, you're telling the calculator that you're taking the logarithm of 6 plus 5, and you're not. You're taking the logarithm of 6 and then multiplying it by 4 and then adding 5. So close your parentheses and then hit plus 5 and then hit enter. And if you do that, you will get 12.1670. Number 13. These are pretty simple, guys, okay? You can type this whole thing into your calculator. Type in 6, then hit natural log, then type in 3.3, then close your parentheses, then hit plus, then hit 2, then hit natural log, parentheses, then type in 1.5, then close your parentheses, hit enter. Now it looks like 21. That's 2 times the natural log. And you will get this right here. 7.9745 rounded. Okay, guys. So 5, 8, what was it? 5, 12, and 16. 8, 12, and 16 are really not that bad, guys, okay? Just type them into your calculator. Alright, no numbers. 17 through 20, we're going to expand. Okay, we're going to expand. So, look at your argument. You're looking for division, multiplication, or exponents. The first thing you usually look for is division. And I have division. So I have this being divided by this. So I write my natural logarithm. I'm dividing two things. So write a natural logarithm twice. The 8 will go right here. And the 6x will go right here. And then, of course, because your argument is dividing, we put a subtraction sign here. Got it? Now, this 8, there's no exponents, there's no multiplying, there's no dividing. We're done with this. I mean, we're not going to cross it off, sorry. We're done with this, but we can simplify this over here, or not simplify. We can expand this. Notice we have multiplication, so I'm going to bring this logarithm down here. Now be careful, you're subtracting. Now here's where students miss this every year. You're subtracting this entire logarithm. So if you're going to split this logarithm up into 2 more logarithms, which you are, this minus sign goes to everything. So you must put parentheses. Okay, you must. So now we're going to split this up into 2 logarithms. So I have multiplication here. I'll put a logarithm here. I'm multiplying 2 things, a 6 and an x. So I'm going to write 2 logarithms. My 6 would go here, my x would go here, and they're multiplying. So I'll put a plus sign, and I'll simply multiply your negative sign through and you're finished. Natural log of 8, negative times the positive is negative. Negative times the positive is negative. And there we go. That's the answer. Number 18. Okay, look at your argument. You're looking for division first. No division. Then multiplication. We have multiplication. And then exponents. Well, we have no division. Like I said, we do have multiplication, and we're multiplying 3 things. 1, 2, 3. So we're going to have to write 3 logarithms, okay? Natural log, natural log, natural logarithm. Now, the 3 would go here, the x would go here, and the y squared would go here. Now, we're going to be adding all of these because all of these are multiplying, so we'll put a plus sign here and a plus sign here. Now, this 3 has no multiplication, division, or exponents. This x has no multiplication, division, exponents. But this argument here has a power of 2. So I'm going to move that to right here. Alright? And then we're finished. That's it, guys. And that is the correct answer. Logarithm, natural logarithm of 3 plus natural logarithm of x plus 2 times the natural logarithm of y. Alright, number 19. Okay, in the argument we're multiplying 2 things. 1, 2. So we're going to write 2 logarithms. Natural logarithm, natural logarithm. 16 goes here. X squared goes here. Because they were multiplying, we put a plus sign here. Now look at your 16. There's no division, multiplication, or exponents. Here there's no division or multiplication, but there is an exponent. So we have not fully expanded this until we move this right here. So there we go. And let's slide that right there. And there we go. Alright. Number 20. Now number 20 I added after I made the assignment. So I've got to copy that down for you. And also the next one. Number 25 I because it's division, we'll put a minus sign here. Now look at this argument. They're all multiplying, and there's how many things that are multiplying? 3. 1, 2, 3. So this logarithm right here will be divided up into 3 logarithms. So 1, 2, 3. Natural log of 2, natural logarithm of x, natural logarithm of y. Okay? They're all multiplying, so we'll put positive signs. Now, here, the 2 simply has to be moved to right here. So, negative 2 natural logarithm of x. Now, there is a couple things you need to notice, okay? I'd give you full credit for this in a test, I really would. I have no problem with this, but you do have, even though you can't see it, guys, there's a 1 in front of this logarithm, or in front of this logarithm here, too. So, look what you have, please, students. You have a natural logarithm of 2, and that's fine. A natural logarithm of y, and that's fine. But you have a natural logarithm of x and a natural logarithm of x. You can combine those. There's a positive 1 right here, and a negative 2 here. A positive 1, it's like adding like terms. If I had x minus 2x, you would put negative 1x or negative x. We'll have a positive natural log of x and a negative 2 natural logarithm of x. When you combine those, you'll get a negative 1 natural logarithm of x. And you do not need to put the 1 if you don't want to. Okay? And that is the correct answer. I'm looking right now at the answer key to check my work, and that is correct. Alright, let's move on to the next 4. Now these are going to be condensing. So that's the next 3. So 25 through 27 are condensing. We're going to condense these logarithms. So give me a second while I copy this one down. This was also a late addition. I decided that we really needed to practice these a little bit more. So okay, students, now we have a couple different ways to do this. If you want, you are more than welcome to take the negative sign and multiply it through. If you did that, you would have 3 natural logarithm of 5. Negative times a positive is negative. Natural logarithm of 15. Negative times a negative is positive. So a positive natural logarithm of 3, and that's fine. And then go from there. In fact, that'll work. And we're going to do it both ways. That's fine. Another way to do it is to simply start inside the parentheses and simplify first. And that's what I'm going to do first, okay? And I'll move to this next. So does everybody see what I just did? I took this negative sign here, I multiplied it times this positive sign here, and times this negative sign here, and I got a negative and a positive. Now we're going to finish this in a second. I'm trying to show you. You could do this either way. Now, if you did not want to multiply the negative sign through, then start right here. Excuse me. We can bring down our 3 natural logarithm of 5. Bring down your negative sign. Put your parentheses. We have 2 logarithms. They have the same base. There's no number to the left. So I can write 1 logarithm. And then they're subtracting. So I take these and divide them. 15 divided by 3 is 5. So there we go. So I worked inside the parentheses first, which is fine. Now, I have a negative sign here, so I'll go ahead and kind of multiply it through times the positive here. And I have 3 natural logarithm of 5 minus or negative natural logarithm of 5. Now, we cannot condense these because there's a 3 here. Remember, you have to move that 3 as a power first. We have to do that first. So now we have the natural logarithm of 125 minus the natural logarithm of 5. Okay? Now these 2 logarithms have the same base. They're both base e. They have no number to the left. So we can take these 2 logarithms, condense them down to 1 logarithm. The 2 logarithms are subtracting, so we're going to divide these 2 numbers. 125 divided by 5 is 25. So the answer is the natural logarithm of 25. Natural logarithm of 25. Alright, moving on to this, not to a new problem, we're going to do it this way now. So if you chose to take the negative sign and multiply it through first, that's fine, no problem. Take the negative sign, multiply it through, you would have this. Now, go left to right. These 2 logarithms here and here have the same base. However, there's a 3 here that we don't want, so we must move this 3 125, right? 5 times 5 times 5. So I have the natural logarithm of 125. So take these two logarithms here, write them as one logarithm. The two logarithms are subtracting, so we're going to take 125 divided by 15. Now, because the two logarithms are being subtracted, now I'm going to leave that a fraction because it is a fraction. I will get 25 over 3. So 125 divided by 15 reduces to 25 over 3. Everybody got that? 125 divided by 15 is 125 over 15. Reduce that and you get 25 over 3. Now bring down your other logarithm. Now, these two logarithms have the same base, and they have no number to the left, so we can combine these two logarithms down to one logarithm. And because the two logarithms are adding, we're going to multiply our two arguments. So 25 over 3 times 3 is 25. 25 over 3 times 3. 25 over 3 times 3 over 1. Your 3's would cancel, leaving you with 25. Either way, you get the same answer. It doesn't matter. Okay? Alright, moving on to number 26. Let's condense this. First of all, do we have the same base? Yes. Next, are there any numbers to the left of each logarithm? Well, yes, there is. So you first have to move this forward before we go any further. There. Okay? Now we can take these two logarithms and we can condense them down to one logarithm because they have the same base. Well, 3 to the 4th power is 81. So logarithm, I'm going to write one logarithm. They're subtracting. So that means I divide the two arguments. So 81 divided by 9 is 9. So the natural logarithm of 9. Natural logarithm of 9. Alright, number 27. Okay, we're going to go left to right. So look at these two logarithms here. This one and this one. Do they have the same base? Yes. They're both base e, even though you can't see it. Do they have any numbers to the left? Well, this one does not, but this one does. So pick it up and move it right here. Now take these two logarithms, and we're going to make them one logarithm. The two logarithms are adding, so we're going to multiply this argument and this argument. So x cubed y. Now bring down your next logarithm. Natural logarithm of 10. Now, do these two logarithms have the same base? Yes, they do. Do they have a number to the left? No, they don't. So we are ready to go ahead and combine these two logarithms into one logarithm. The two logarithms are adding, so we're going to multiply their two arguments. X cubed y times 10 would be 10x cubed y. And there we go. Okay? Alright, now moving on to two graphing problems and we're finished. These are actually going to be easier than the ones we've done before because you can actually enter this entire thing into your y equals window if you want to. Let me first show you how to do that, okay? So with your calculator, go ahead and hit y equals. And when you do, of course, hit the y equals button, and then you can type this in. Then hit ln for natural log, then parentheses, x plus 2, parentheses, then negative 1. Now I'm going to go ahead and type that in now quickly. Give me a second to do that. For those who do not have a grapher, no big deal, no problem. Let me just type this in, and I'll talk to you guys in a second, okay? Alright, good. Now let's all listen. The first thing you always do when you're graphing a logarithm, hey, you know what it is, guys, I've taught you this. You take the argument, set it equal to 0, and solve to get your vertical asymptote, okay? We know this. There's your argument, set it equal to 0, and solve. So there's your vertical asymptote, negative 2. Got it? So now go ahead and draw your coordinate plane, and at negative 2, put your vertical asymptote. That's pretty simple, guys. Really it is. Alright. Now, next what I taught you to do is you're going to write a table of values that has 5 ordered pairs, okay? But the problem is do we go to the right? Either your graph's going to be on the right of this asymptote or the left. So you're going to have to decide. We're at negative 2. So the two numbers we're going to test are negative 3 and negative 1. Alright, negative 3 and negative 1. Now which one of those would give you, well, a negative number? Negative 3 is going to because negative 3, if you put negative 3 in for x, negative 3 plus 2 is negative 1. You cannot take the logarithm of negative 1. It's impossible. So I know I don't want to put 3 in. So I know I'm going to work on this side over here. You got that? So I know the graph's going to be over here somewhere, not over here, because negative 3 gives me a negative number for the argument. So I know I'm going to be over here, so try to get real close to that asymptote. Okay, 0, negative 1, negative 1.9. So I got real close to it. Negative 1.9, okay? Now, then negative 1, 0, so on and so forth. So negative 1, and then 0, and then 1, and then 2. Now, here's why this is going to be so much easier, guys, to graph than the other ones we've done. They're going to be easier because you can actually, first of all, if you have a grapher, then go ahead and look at your table of values, and you can fill these in. You can fill those 4 numbers in, okay? What about 1.9? Well, we'll talk about that. Now, for those that don't have a grapher, we can type these in so quickly, guys. Come on, think about it. Put a negative 1.9 right here. Got it? What's a negative 1.9? And if you don't know, type it in your calculator, okay? Negative 1.9 plus 2 is a 0.1. So you have a natural log of 0.1 minus 1. Make sure you put parentheses around this. So type it in. Hit natural log 0.1, close your parentheses, minus 1. And you will get negative 3.3. Now, for those that have a grapher, you can just fill in your table of values using your grapher. For those that do not, let's continue on. You have a negative 1. Put a negative 1 right here. What's a negative 1 plus 2? It's 1. So the natural log of 1 minus 1. Well, we know by now, guys, the logarithm of 1 always gives us 0. So the natural log of 1 is 0. Minus 1 is negative 1. Next, let's use 0 for x. So we'll put a 0 right here. 0 plus 2 is 2, so the natural log of 2 minus 1. Natural log of 2, close your parentheses, minus 1, enter. Negative 0.31. Negative 0.31. Okay, next we're going to put 1 in for x, okay? 1. So put a 1 right here. What's 1 plus 2? 3. So the natural log of 3, close your parentheses, minus 1. So ln 3, close your parentheses, minus 1, is going to give you 0.0. We're going to round it to 0.1. It's 0.098, so 0.1. And then lastly, we're going to substitute 2 into the logarithm. And we can do that in our head here, guys. 2 plus 2 is 4. So the natural logarithm of 4 minus 1. So ln, and then 4, then close your parentheses, minus 1, gives you 0.386, or 0.39. Okay, guys, I think we're pretty much ready to graph this. We'll do one more, and we'll be finished with the homework assignment, okay? Here we go. Alright. Now, negative 1.9, negative 3.3, so about right here. Negative 1, negative 1. 0, negative 0.3, so 0, negative 0.3. 1 is a 0.1, and 2 is a 0.39. So we're getting a pretty good look at the curve here, the graph. And there's my logarithmic function, getting closer and closer to the vertical asymptote, but never crossing it. And that's it, guys, okay? Let's try one more. Alright, number 42. Now, first of all, you take your argument and you set it equal to 0 and solve to get your vertical asymptote. So my vertical asymptote is at 1, okay? So here we go. There's my vertical asymptote right at positive 1. Very good. Not too difficult to do. Now, the only thing is, we now have to decide whether the graph's going to be over here somewhere or over here somewhere. Okay? So let's see if we can figure this out. We're going to have to try 0. That's to the left, and 1 to the right. Well, guys, think about it. It's so obvious. If I put 0 in for x, I'm going to get the natural logarithm of what? Negative 1, 0 minus 1. So there's no way 0 works. There's no way the graph works over here. Okay, so I know the graph's going to be over here to the right, over here. So I'm going to get real close to this dotted line. Let's see, 3, 2, that's 1.1. I'm barely to the right of 1. So in my table of values, I'm going to start off with 1.1. And then move on to 2, 3, 4, 5, 6, etc. So 2, 3, 4, 5. Okay. So let's just kind of throw this down here real quick, give us some room. We'll pull that back up later. And let's get to work, okay? Alright, we're going to put 1.1 in for x, okay? So 1.1 minus 1 is 0.1. So 2 negative natural log of 0.1. So with your calculator, type that in just like it is. Oh, by the way, if you want to use your grapher, of course you would hit y equals, and then 2, and then minus, and then natural log, then parentheses, x minus 1, close your parentheses. That's how you would type into your grapher if you want to use your table of values, okay? Now for those that do not have a grapher, we're going to have to type this, we're going to have to type this into our calculator right here. And it's so easy to do. You simply hit 2, then minus, then natural log, and then 0.1. I mean, it's really simple. And you will get 4.3 if you round. 4.3. Now let's substitute 2 in for x. Okay, 2. Well, that's not too difficult to do. Put a 2 right here. What's 2 minus 1? 1. So 2 minus the natural logarithm of 1. Well, guys, we've learned this. It's a property, it's a rule, it's a law. Anytime your argument is 1, then the logarithm of 1 is 0. The logarithm of 1 is always 0. I don't care if it's a natural logarithm, common logarithm, I don't care what the base is. The logarithm of 1 is 0. So this equals 0. So we have 2 minus 0, which is 2. Okay, moving on to 3. Let's substitute 3 in for x. 3 minus 1 is 2. So I have 2 minus the natural logarithm of 2. So type that into your calculator. 2 minus the natural logarithm of 2. 2 minus the natural logarithm of 2. And you'll get 1.31. Now let's type in 4 for x. Or let's substitute 4 in for x. Put a 4 right here. 4 minus 1 is 3. So 2 minus the natural logarithm of 3. 2 minus the natural logarithm of 3. And that's going to give you 0.90. 0.90. And then next we'll substitute 5 in for x. 5 minus 1 is 4. So 2 minus the natural logarithm of 4. We type that in. 2 minus the natural logarithm of 4 would give you 0.61. And now I think we're really ready to pull our graph back up here and do some graphing, alright? So here we go. Alright, my first order pair is 1.1, 4.3, so over 1.1 and up 4.3, so about right there. And then 2, 2, so over 2, up 2. And then 3, 1.3, so over 3, then up 1.3. And then over 4.9, so over 4, up 0.9. And then over 5, up 0.61. And there it is, guys. The usual curve that you're going to get when you're graphing exponential functions or logarithmic functions, okay? And it will continue to go down and down. It will also continue to go left and left. However, it will never cross that asymptote to the left. And there you go. Guys, I hope that you're using these homework help videos to help you. I hope this video was a help. If you have any questions, never hesitate to